time and joining us to listen to what we have in store on MeshWorks 2020. And I hope you're all staying safe and social distancing is in place, but we still have a way to connect with you over the web, as close as it can get, to discuss about MeshWorks 2020. My colleague Gautaman is joining me, and he's trying to get the slides on the screen for you. Share it on the screen for you. So while the MeshWorks, the slide set is coming up on the screen, just wanted to give you an overview of MeshWorks 2020 and what is it that we're going to discuss today, as how MeshWorks helps us to handle the workload as far as the hybrid and electric powertrain systems are concerned. That's what we are going to look at today. MeshWorks 2020 was launched early this year, and the previous versions are very well known to you, and we had several webinars of the previous version as well, and we explained how MeshWorks, as a leader in morphing and parameterization of finite element and CFD models, graduated and moved up to become a preprocessor and becoming a CAE platform handling all your modeling needs. And that was the essence of the earlier version of the MeshWorks. And with this 2020 version of MeshWorks, we are almost ready as an engineering platform, so to say, in the sense that the entire pre and post processing is one part of MeshWorks 2020. There are all the other important elements that we have added up under ConceptWorks that really comes into play and helps you quickly synthesize finite element models. And especially that's very useful to you from the perspective of body structures or powertrain, or for that matter, the chassis systems in the automotive context per se. Besides that, another very important attribute of MeshWorks 2020 that would come across to you would be upgraded parameterization techniques, and also the process automation engine, wherein we can automate a lot of CAE standard operating procedures without really having to be an expert in the programming language. And those are some of the things that we are going to look up today, and mostly in the perspective of how we are going to use MeshWorks 2020 to put together a battery systems model. If we want to, let's start at a cell level and then start doing the connections and make up a cell stack, and take the cell stack and put it inside a battery housing and top it up with a cover. How do we prepare such a model for crash simulations? How do we prepare such a model for a durability simulation? That is something that my colleagues are going to walk you through today. And as the next part of it is the motor, which is very important in our hybrid as well as electric propulsion. We're going to demonstrate to you using a demonstrative simple model, though, the process of modeling up the stators and the rotor side of the motor, and also the motor housing, and then all the connections which go and make motor an integral piece. And we're going to look at it from the NVH as well as the durability perspective there as well. We're also going to present our IPAM, which is the integrated parametric associative and automated modeling option, which is very important piece of the pre-processing in MeshWorks 2020. We're going to present you that through how it really helps in transmission and transaxle modeling. And also, how do we model engines? Engines are going to be there in the hybrid drivetrain scenario anyway. So we are going to look up at engine models and how our IPAM module helps there. So with that sort of an introduction, I would request my colleague Gautaman, if he's still able to hear me out there, to start sharing the screen, and let's go ahead and start the demonstration.
Yeah, sure. Yeah, thanks for the introduction. So yeah. I'm going to start off this with a couple of examples of how do we model battery cells and integrate them to the battery cover and so on. And what are the benefits while using MeshWorks for this process and how efficient it is. Starting up, first one is when it comes to battery modeling. Here, as we can see, the parts consist of variety of modeling techniques. Like a couple of them could be shell models, some of them could be tetra mesh models, and some of them could be hex mesh models. And the next part is also the connectivity. So the connectivity also could be a seam weld or a 1 bolt, also a 3D bolt. So by nature, it is very complicated to model all of them. So now we can see how MeshWorks can be efficiently used to model these kinds of assemblies. So the first one is how do we efficiently model battery cells. As you can see here, we have modeled the anode plate and the cathode plate using a mesh template, and then we have covered it with the coolant plate, and the coolant plate is connected to the anode and cathode plates through 1D connections like beams and rigids. And then finally, these models are stacked to create a fuel cell, and then the fuel cells are integrated into a battery housing. So all of them can be created using mesh templates. And now we are going to see in detail how do we do that. So coming to the next topic is on the electric motors. This is where we go into detail of the process. So here we have how do we model rotor stators and how do we connect them together. So the first one is we have an assembly of model, which is the CAD model. And in this assembly, we have a couple of parts which are tetra mesh parts, and some of them are hexa mesh parts. Now, when it comes to tetra meshing, it is as easy as a push of a button. So here the user can select a CAD data, whichever he is interested in, provide a mesh template which takes care of the element size and the feature conditions like fillets, tubes, washers, etc. And then a quality template. Based on that, we get a very nice output with very minimal interaction. And then coming to the next topic is our hex mesh creation. So for the hex mesh creation, we have variety of function. And in this example, we are going to show a very couple of functions. So here the tool automatically identifies its symmetrical part and gives you a sector of a model, which is being meshed as per the quality and flow and replicated. And then we use something called as a parametric extrusion. Even though the model is having various depths, the parametric extrusion tool automatically segregates them and gives to the user in a one push button like this. And similarly, if at all we might be having a lot of gears in the model, so MeshWorks can nicely be used to create these kinds of models as well. So just like the previous example, automatic identification and segregation of a sector of a gear tooth, and then meshing them as per the meshing standards, and then creating a kind of parametric extrusion output, as you can see here, and then using this output to replicate and recreate the full gear tooth of the model. So here we have seen a kind of a detailed modeling. What if we want to use simple modeling techniques, like in this case, solenoid wires. So even though the CAD is very detailed, we would like to create a kind of a very simplified model for our analysis purpose. So that is also possible. And the next one is, after creating the meshing, we need to assign the materials and properties to the model. So here we use the assign bill of material functions, wherein the materials and the properties are given through CSV files, and then the bill of materials is assigned. The second portion is going to be how do we connect all the parts. So connection is through two types. One is through contacts, rigids, and bolts. So in the case of contacts, the user can just simply select all the components, and based on a tolerance, the tool automatically creates all these kinds of contacts. And the contacts can be a tie contact or a simple surface contact. And now we have to do the bolt connection. So in a case of an Astran model, the bolt connection is going to be a 1D bolt representation. So like something you see on the screen now with a rigid and a bolt, which has been represented by a beam. And then if at all, if you want to create a very detailed modeling, like a 3D bolt, that is also possible. So basically, the user can use templates which is available in MeshWorks to very quickly create the mesh. And the connectivity also can be created using the templates, like whether it is a 1D bolt or a very detailed 3D bolt. So here, MeshWorks automatically identifies the areas and gives the option to the user whether he would like to have a tetra bolt or a hexa bolt with what dimensions and so on. The user is not creating this bolt manually, but rather the tool is taking it into automatically. So yeah, so the next topic is going to be on the transmission housing. So what are the benefits the user can get? So we have a very cool wrap function which automatically takes care all the quality criteria based on the CAD data provided. And then the second one is how do we create the auto parameterization and what are the benefits using all these functions, like Karthik mentioned the IPAM. So number one, since we have a templatized batch machine process, it's fast. And on top of that, we also have the auto parameterization capability, wherein with a single push of a button, wherever required, the user can create all these parameters like the fillet radius change, the rib height change, and so on. And now that we have built up a single model, like let's say a durability model, with this model as a reference, the user can now create various other attribute models like an Astran model with a different mesh template and a different connectivity and so on. So now we talk about parameterization and design changes. So as we do changes on this FE model, how do we bring about all these changes to replicate on the CAD model? So that comes to the next topic of associative modeler. So here we have a CAD to mesh associativity and mesh to CAD associativity. So here you are seeing a baseline mesh and an optimized FE mesh and a baseline CAD. With these three information, MeshWorks very nicely gives you the optimized CAD output, which can be shared to the CAD engineers to do all the preliminary studies like the cost estimation, die design, and packaging. These are all the very important factors of the MeshWorks, how easy and efficient it is. So I would now like to stage to Karthik to give the brief summary.
Thank you very much, Gautaman, for all the demonstrations on battery as well as motor and then the transmission and the engine. I think this is the way we are trying to bring in a lot of efficiencies, if you see, through our IPAM module. So with that, we would like to share with you what is the takeaway from this session. So as you really noticed, one of the very important point that came up was the ability to when we created an engine model, we were able to not only create the mesh model with all the connections, that's the regular pre and post processing game, but we were also able to parameterize a lot of the entities, especially the rib heights or the wall thicknesses. So that is something that you see here as part of the benefit that the user gains from parametric modeler. Also, in the context that we looked at both the battery models and the motor models, if at all we can start off with a single CAD, for example, like how we started off the motor, and if we can have a meshing template as well as the connection template and the solver attribute template, it is possible for us to generate a mesh in the NVH model as well as the durability model of the motor simultaneously. That's the benefit that you gain from the integrated modeler. And as you saw on the transmission model, we were very nicely able to connect the changes that was done on the CAE model and tie it back to the baseline CAD model. So that way, the entire process was almost bidirectional seamless. So that is the benefit of associative modeler. And also, please note, the associative modeler is also a very important pillar as it helps you to reuse your existing mesh. As a team, we have several mesh models available from our previous product lines. And if there is a new CAD data that is coming in and it is a variation of an existing product, you can depend on associative modeler to sort of take the existing one and improvise that with maybe addition of 4 more ribs at certain areas and certain more adapter holes in some other zone. So MeshWorks updates the existing model with all the dependencies, and that way there is a very powerful option that you have in MeshWorks that takes care of it. And together, as you can see in this slide, there is a little circular diagram, which is what we see as the simulation framework that the next generation engineering cycle would bring to us, wherein we have to look at the simulation with an entire framework of the engineering data that it generates, and also the suitability to adaptive manufacturing techniques. And also a lot of the data might be operating on a cloud, so we should be ready for that. And also we should be ready for a model-based design or a system integration kind of a scenario where CAE either co-simulates in a framework. So an automation is also a very important part of it. So with all these forces playing around in the simulation world, we certainly feel the IPAM platform that is presented to you on the screen is very well suited, and it really matches nicely with the circular diagram in terms of the other important technology pieces that are going to come together to the simulation engineers, as we can see. The next important slide talks about the real benefit that we are going to gather today based on what we have seen. Is with the integrated modeling, we have eliminated the process where the user or an engineer creates 2 models. He sort of replicates the entire meshing procedure, again, connections procedure, and the solver deck setup. That replication is all gone. With the help of the solver templates and connection templates, they get done automatically through the integrated modeling. And the process automation is also something that you stay tuned to hear from us in the next webinars as we address MeshWorks 2020 there. We are also going to present how we are able to make a framework to automate the CAE SOPs without having us to master certain programming languages. And that's a very user-driven methodology so that we want to present. It's very, very interesting as such. An associative modeler, I already mentioned to you that it's the best way to reuse your models. And parametric modeler is a great way for you to explore designs and create several design options and study them and make the what-if scenario investigation almost CAE-centric, in which case that we don't wait for CAD. We just go ahead, parameterize the model, and run the simulation and check out what's the outcome. And in a nutshell, what we want to present to you from this today's webinar is a very simple message, as DEP MeshWorks 2020 is a platform that addresses the product development process right from the concept stage. It has all the tool sets to help you really do a lot of upfront simulation work with its ConceptWorks tool sets, as well as with morphing and parameterization tool set. You're almost ready to synthesize your models faster, optimize your models faster right at the concept stage. As you run into the detailed design stage where a lot of CAD development has already happened, MeshWorks comes in handy to you to build your models, mesh models faster, connect them, and also use the IPAM modules to get all the acceleration that you need. And again, here also the parametric model comes into picture. Parametric CAE models help you to do the design exploration even more at the design and development stage. Last stage, as we get into manufacturing side of it, where we still want to check few things from the manufacturability perspective, especially maybe the heat affected zone for the seam welds, or maybe the weld optimization or the adhesive optimization, or the ability to map the weld distortion in the assemblies back into the finite element model. All of those 9 yards are taken care of by MeshWorks when we are looking at it from the manufacturing angle. If at all we want to do reverse vintage in plastics, which is an outcome from the Mount Flow kind of simulation, and we want to superimpose all the warping on the part back on the baseline CAD data, and we want to understand what countermeasures that we can take to reduce the part warpage. Guess what? MeshWorks tools are ready to help you there as well. So in an essence, MeshWorks as an engineering platform from its version 2020, it's ready to help you on the body structures, powertrain, be it hybrid or purely electric, and the chassis systems which carry either a hybrid or an electric drivetrain, and also the interiors and exteriors of the vehicle. So this is what we had to mention to you today in terms of introducing what MeshWorks 2020 has in store for you. We would request you to stay tuned. We have many more interesting messages, as well as some of the important tools that we look forward to demonstrate to you, which really would, we feel, would help you save time in our engineering process, and also helps you to explore the design more than traditionally using up the time to build up the models. So that's the philosophy that we want to bring up and present to you in the next webinars. Kindly stay tuned. With that, we are open for questions, if any. That way we can answer them. Right. So some of the questions that are on or all on the hex meshing is especially. So I think yes, predominantly the, as you saw on the motor component, as well as on the battery systems, we would have certain components modeled as hexa and certain other components modeled as tetra. Perfectly, MeshWorks has several hex meshing algorithms beyond the regular ones that we are used to in terms of solid mapping options, as well as the solid meshing options, linear solid options. All those options are all available in MeshWorks. And where it really scores on hex meshing and capturing different geometries that you see in battery as well as on the motor is the extruded hex meshing, where we are able to capture all the features, take them to a plane, mesh them, and actually extrude them. So we are going to again demonstrate in detail that in one of the webinars that is upcoming. Stay tuned, and that will answer you the question on the hex meshing. And certainly the process is more efficient. It sort of saves you close to 50% of the time in certain complicated components to generate a hex mesh, if you're looking for that. And another question is very interesting. It sort of says, what is your comparison with other tools that we are using and that are existing? Very good question. So here in MeshWorks 2020, what we have made is an attempt where it really places itself as a horizontal engineering platform, catering to all the vertical requirements of a product development cycle. The vertical requirement, if it comes from the concept stage, MeshWorks has all the tool sets to accelerate the processes of building up a concept model. Later on, going into the detailed engineering phase, MeshWorks has all the tool sets to take a CAD data and do all the mesh modeling, as well as the connections and the loading and boundary condition setup, and creating a solver ready input data deck. And also the parameterization comes into picture there, where MeshWorks has extensive ways to parameterize your finite element model. It is no more restricted to shape. It is not restricted to the thicknesses. It is not restricted to materials. It can handle a lot of design enabler parameters like beads, bulkheads, or the topology parameters, or doubler kind of parameters. So it is very rich and very extensive. So all those parameterization can be brought in the finite element model, which makes your design exploration very easier. And you can be, the entire process becomes rich with data, so that we can do a lot of data-based activity on top of that. And it also caters to certain level of manufacturing CAE as well. So with this, what we are comparing against is all these are available in a single canvas that we can flip through, including the post-processing modules, by the way. So it's a very connected single canvas that gets you all the way from concept to manufacturing CAE. It has all the modeling tool sets and the concept model building tool sets and the morphing and parameterization leadership for you to get it. And that is sort of, I would say, the comparison that I would place against that for that question. The other question is also to see how do you bring about modeling windings, especially in the motor. Yeah, I think we're going to address a separate session on that. We have certain process automation tool sets that are created already, which handle how do we go from a wire to a braid, and then how do we make it into a bundle, and then we twist it, and then how do we wind it. So we have generated some process automation routine for it. I think we would, in one of the next webinars, we can come up and discuss that as well. So those were some of the questions. And also the other question is that, is it only a CAE model builder? Does it have any modeling tools for CFD? Absolutely, yes. This is a platform, though today you saw only the models, modeling demonstrations, which are more catering to structure models. But absolutely, yes, for CFD modeling, also we do have certain tool sets, especially the thermal models. That was the question when you saw the engine model. Yes, it is right. We do generate very nice skin mesh models, which are input for your polygonal mesh generation in a CFD application. So I think those were some of the answers that we wanted to bring up to you and share with you. I think those were the summary of the questions that we had got. Thank you so much for taking your time and joining us live for this webinar. We look forward to keep you updated on the next series of interesting topics that we are planning to take up and demonstrate to you the value that MeshWorks brings in. Until then, stay tuned and stay safe. Take care. Thank you.